can feel comfortable that both versions work just fine. One of the things after this consolidation, we looked at it, and I'll maybe briefly share the rev define here. So you see that this thing has gone up. This was averaging about 1,800 since we were doing the epoch, but with the consolidation, this has gone up to 2,100, which I think was where we were before, because last I remember we saw, like I was saying, that there's a 16-17% drop, and basically that seems to have come back up. But again, at this point, we're not too focused on these performance measurements and what's going on, but this is something we will certainly look at and see what's contributing to this increase. The main part, let me now switch back to the report. The main part on performance is going to be after we have the initial version of the block merge, and we'll begin to measure that and see what we're gaining where. And as well, we're right now in the process of putting together the measurement frameworks in. So that's what I wanted to say about the releases and the nets. There has been good progress on the block merge. The team is continuing to work through that. NetZipper is close to completing the conflict resolution based on the that's essentially about checking for race-free conditions. So we should soon have a early release candidate for that. And then as we run it on the network, so we will begin to see what kind of improvements are needed. So that's what we're working on. The only other main issue, or the other PR that came in here, is the a PR to use Scala vectors instead of list to represent the event log information that's currently being reviewed. And again, that also we'll see if it has given us any performance boost once it's merged. That's where we are. And then a bunch of dependencies have been updated. There are a couple of PRs related to dependencies updates. And we still have a few more to do. In the current round, cats and other dependencies are updated. But for the performance monitoring and measurement, we'll be updating the KMON, Zipkin, InfluxDB, those kind of dependencies. And eventually, we want to see how complicated the migration to Scala 2.13 is. Scala 2.13 does have some breaking changes, so we need to take a little bit of time to get there. But presumably, the good news with Scala 2.13 is that once we resolve those conflicts and get ready for 2.13, the migration to Scala 3 will be easier. That's the promise of Scala 2.13. So we'll take it in steps as we go along. Rholang 1.1, Joe has made the demo in the last session, and that work is completed for now. The team has reviewed his PRs and had some questions and suggestions, but by and large, the work is complete at this point in time. And I wanted to mention that Dan Conley made a comment in one of the channels that even though it may take us a while to migrate to Rholang 1.1 on the mainnet, because we have to rewrite all those contracts and then test them and make sure there are no problems and all that kind of stuff. Dan pointed out that it's a great developer tool, meanwhile, to write your contracts in Rholang 1.1 and have it generate the corresponding Rholang 1.0 code that's running on the mainnet. So this is something I encourage everybody to try out and see how that works, because Rholang 1.1 is the future, and to the extent that it's source-to-source translation right now, you might as well start using it. At least from a user perspective, the code looks very nice and compact. You will see when you generate from 1.1 to 1.0, the 1.0 version is a lot longer. So at least it saves you some cognitive complexity if you begin to get used to 1.1 and use it, because you're reading a smaller snippet of code. So, and I already talked last week about what all we have to do on the back end to make everything be 1.1 native. So that'll take a little bit of time. So I'm not going to go over that again now. There's been no changes to APIs or any of this other stuff this week. I think that's mostly what I wanted to say. Are there any questions, comments from anyone on this? All right, over to you, Greg. Thank you very much.
Oh, thank you so much, Ro. No, actually, even our small updates are good updates. I did want to also point out that wherever you see the expansion, the automatic expansion from Rholang 1.1 to Rholang 1.0, all of that extra code can be optimized away. So as an example, if you were to apply this to the systems contracts for the wallets, all of the stuff that's just about communicating values from one portion of a program to another does not have to go out to storage. It doesn't have to be recorded as a transaction against the blockchain. And as a result, we should be able to get like the 400 COM events that are in wallets, on wallet transactions on average down to about 200 COM events or less. So Rholang 1.1 will be responsible for a significant speed up as we move towards optimization. So not only will we get speed up coming from block merge, but we'll also get speed up coming from Rholang 1.1. And all of this is still just a low hanging fruit. We haven't really done any serious optimization on the network yet. Any questions about Rholang 1.1? Okay then. Oh, anyway, I think it's a very good. It would be very good for the community to engage Rholang 1.1 sooner rather than later. The more we have people writing Rholang 1.1 programs, the better off we are in terms of making sure that it passes muster. An example of the kind of thing that might be useful would be to take all the smart contract code for RVote 2020 and rewrite that in Rholang 1.1. That would be a great update for the AGM in 2021. So if anybody wants to take that on, let us know, and we can probably allocate a bounty for that. All right, moving on. I would like to talk a little bit about work that some feasibility study work that the co-op is going to do with a new chipset. So I can talk about that. Since Steve Ross Talbot is on the call, we might want to schedule any updates on the COVID wallet to the community earlier. It's stuff that Steve, you can talk about that isn't better suited to the closed door session. And we also have the community in review. So my guess is let's go with any updates from Steve, and then the community in review, and then I can touch base on the hardware development.
Yeah, sure.
So go ahead.
Okay, so yeah, brief update. So the guys that are working on the test wallet on the COVID passport, which is really a generic thing. So it presents as a file browser based upon your address. And it has inbuilt into it the 3 signatures that give what I've been calling a digital asset authenticity. So if you think about a COVID vaccination, you want the doctor to sign, you want to sign, then the doctor signs on top of you, I think, and then that gives it the authenticity that means somebody can trust it. And the work that's gone on, so there has been actual concrete work. It's not just the YouTube video. If any of you haven't seen the YouTube video, then reach out to me and I'll send you a link, because that sort of documents what we're trying to do roughly. But the actual demo, which is in place now, running on testnet, has this authenticity aspect to it. So anything that's authentic shows up as a green kind of file icon. And if you clicked on it and uploaded it to your browser or whatever, then you would see that asset. So in the case of a COVID vaccination, you'd see the COVID vaccination certificate. And that's the sort of thing that would enable you to pass through borders and all sorts of other things. And yet you're in control of your digital assets. And that's a really key thing. There's been a lot of nervousness about this at the moment in the UK, because people are very nervous about the centralization of that information. So we might have hit this at a really good time. In the world of British politics, at least, and to some extent European politics, there are a number of people who are well-known spokespeople. They're not politicians, they're journalists, commentators and stuff like that. They're quite influential in trying to figure out how to get to the people that have a budget to fund such a COVID-19 passport. Because obviously, if you're in the UK, it might be that the UK government or the NHS gives the doctor a certain number of rev to enable them to produce and sign a document. And then you get some rev possibly from the government because the NHS is free at the point of use. So you've got two parties that need that rev. Ultimately, it would be the government in the UK that would have to do that. Now, to get to the stakeholders that would actually fund such a thing, we need both people in the NHS, who are significant people, who are a route to the budget holders, and we need significant people who are a route to the WHO at the same time. So we're trying to do both, and we're also trying to reach out now to the United States, so back into the US. So anyone that has contacts with the Biden administration, it would definitely be a good idea to share the video link, the YouTube link, that I will post. You've all got it, right? So I'll post it there, then anyone can get it. I really would like help from members. So if there are people, you know, the game here is not can we do it, we can do it. It's not that hard on RChain and with Rholang to do this. It's really not that hard at all. But what is hard is finding the right people to talk to who have the budget. So think of this like a sales process. We're walking a ladder. Where we're trying to get to is the guy or the guy that has the budget, who's the signatory. There will be various people in between, some of whom will be coaches, some of whom will be gatekeepers, and we have to navigate each of those to get to those budget holders. What we want to do is have the wallet working and have the COVID passport working in practice. And at the point that I am called to have my vaccination, if it is working, I will ask my doctor, who is a personal friend, to become a member of the co-op. I'll pay her to the $20 because what I want to do is I want her to do this live. I want her to use her mobile phone. I'll have my mobile phone and we'll actually do it together. And I expect that to happen in roughly the next 6 to 8 weeks. What I'm hoping is that at the same time, we find the right people to talk to and get nearer to the budget holders. And if we can get to the budget holders really quickly, then, you know, game on. Then let's see if we can crack this thing. So that's kind of where we are. I do post stuff on one of the RChain channels in Discord to do with identity, I think, and agency. So I do try to post little updates in identity and agency. So look there if you want to see what's going on in general. And if you go to identity and agency, you will see Lamouette posted the demo. So you can see the RChain file manager, you can see the green icons, which have been authenticated. So yeah, we have the mechanism to do all this now. Now it's just about tidying it up so that when I am called for vaccination, because fortunately I'm old enough to be likely to get the vaccination in the next 6 weeks or so. So I'm hoping to actually do it myself and record the fact that I'm doing it. And Tony Blair came out and said, we need a COVID passport. That often means, given Tony Blair's credentials with the Iraq war, that people go in the other direction. But the fact that even he's now saying it is kind of interesting. That's where we are.
I bet that we should be able to find some journalists that want to come down and film you.
Well, I'm going to let George Monbiot and Richard Coker, Professor Richard Coker, who are journalists in their own right as well, The Guardian. I bet that, I mean, I'm going to let them know. But yeah, when we get to that point, if I've lined up the doctor, it's a personal friend. My wife is her son's godmother. So I'm pretty sure I can get her to do it. It won't be binding, but it will demonstrate live the real thing. And I think you're right, Greg. Maybe this would be a great little BBC 30-second piece, wouldn't it?
It would be. Absolutely. Absolutely.
A good idea.
You know.
That's why we have members, guys. Get your thinking caps on, get excited, and see what you can come up with. Some of you guys might be going through the vaccination process, and if you are and this thing's ready, use it. See if you can use it.
Absolutely. That's very exciting. That's very exciting. Any questions for Steve? Okay then, Daryl, are you ready for the community in review?
I am ready. Yes, I must admit, though, I'm a little distracted by watching the most bizarre moment in U.S. history unfold live on the news right now. But,
what are you seeing? What's going on?
well, they've breached the Capitol steps, the protesters, and it looked like the Senate floor was being evacuated, but I think they're just in recess. But the Republican National Committee headquarters has been evacuated. It is totally bizarre. Anyway, it's just strange watching the science fiction comedy Idiocracy unfold before our very eyes.
I have to say, it's very strange to have this. You know, I keep hoping for revolutions that are more like the Summer of Love than than this style of revolution.
It's quite bizarre. And I'm sorry, I'm distracted, but yeah, crazy stuff. Okay, so last Thursday and Friday we're off because of New Year's Eve and New Year's Day. So this week kind of started on Monday. And so on Monday at Casper Stand-Up, this week's Casper Stand-Up discussed a refinement of the radical fault tolerance calculation to getting closer to a much more efficient implementation of Casper. And then at 10 a.m., the RDev member group planning, Derek Lance is outlining the insurance requirements for staking risk pools for RChain and other platforms. Derek is a Florida-based insurance agent. On Tuesday, yesterday, we had the communications working group call. We discussed blog article topics, putting a roadmap timeline on the platform page of the website, Nora's list of YouTube influencers that we can approach, and the goal of having materials in place for block merge when we employ an outside PR firm. At 11 yesterday, we worked on, the DApp developer working group worked on liquid democracy issue creation. And this morning, just an hour ago, RChain Active member hangout, they discussed Rholang 1.1, Raphael's work on the Get Started page of the rchain.coop website. He's just kicking butt right now. The strategic plan draft, and Raphael's concurrency article draft that he's working on, and DApp ideas in log-rdev. And that brings us to now.
Awesome. Very good. Very good. Any questions for Daryl? Fiber has a question for you, Daryl.
Answer is yes, you'll get your walk after the community hangout.
So I do want to mention that over the New Year's weekend, I spent some time. You know, for the math, I need to do this kind of long form thinking, which means I can't have a lot of distractions. Like, have you filed the PPP forgiveness papers? Oh, we need this form in order for us to file that form. That kind of distraction is anathema to the kind of long form thinking I need to do to really work out some of the more subtle technical stuff. But over the New Year's weekend, I had some time, and so I spent more time thinking about the radical fault tolerance. For people who may not know or need some reminders about what that is, it turns out you can define an analog of this square root process, or the square root operator for processes in the row calculus. And when you work it out, when you do the calculations, it turns out to be a form of fault tolerance. It allows you to make copies of a process, all running in parallel, sort of be equivalent to or bisimilar to just running the process once. And that's effectively what Casper is doing, right? So each of the nodes are all running independent copies of the same process. And what Casper is doing is ensuring that all of the different executions are all in agreement. So the square root idea is very similar in shape and form to Casper, but it does things a little differently. And if you look at the way it does things differently, it's in many ways a lot more efficient However, there are things that Casper is doing that this calculation does not address. One example that's very important is Casper is addressing issues like message delay or message loss, right? So if you, the square root calculation makes an assumption that all communication is perfect, which is not always going to be the case. So Casper addresses those issues. Now, one of the more interesting things that it turns out comes out of this is that you can compose the square root calculation with the work that was done about a decade or so ago using the error correcting codes procedures. So you can directly apply the error correcting codes methodology to make a version of the square root calculation that does in fact address message delay and message loss. So you can kind of take another step from where we are to something that's as robust as the implementation of Casper that we've got. There are other pieces of the puzzle that are a little bit more tricky that have to do with verifying verifying that what a validator is reporting that it's running is in fact what it's running. So that's where some of the cryptography comes into play in Casper, and so there has to be a similar kind of apparatus that is mixed in. And it turns out that there's a really good apparatus or framework for looking at that. The biggest question is whether or not that's performant. So Mike Stay and I spent a little bit of time talking about that this past Monday, and so I will be doing some investigation there. If it turns out that this pans out, we may have a variant on Casper where the proof of correctness, which includes liveness, fairness, and safety, is equational. So that has always been the goal with respect to these kinds of things. Even just the proof of safety for Casper is as currently laid out is full of a lot of English. It's not the kind of thing that you could readily feed into a theorem prover like Isabelle or Hall or Cook. Any of those, you're going to have to do a lot of work to get it to the place where you can just feed it into a theorem prover and have the theorem prover automatically make the proof. You know, the aim is to get the thing as close to a completely equational proof as possible, so that the proof of correctness can be completely automated. That's the aim and the goal, and this work is in service of doing that, while at the same time producing an architecture that is at least on the surface considerably more efficient than the implementation that we've got. Any questions about that? Okay, all right. One other thing I want to point out is that very recently, like in the past year, there has been a breakthrough in obfuscation. So in particular, there is a new algorithm for what's called identity obfuscation that it's a bit of a holy grail in terms of the kinds of things that it would allow cryptographically. One of the upshots with respect to identity obfuscation is that it would allow us, if we were to, implement it, if we were to find a version of the algorithm that would, be performant enough to run on chain, then it would allow us to store private keys on chain without there being a problem. Like today, for example, with the COVID wallet, we have to use basically a form of Diffie-Hellman to get around some of the encryption constraints with respect to storing private data on chain. But with this new identity obfuscation algorithm that was published just this past year, it would allow us to greatly simplify a lot of that mechanism. which makes it even easier for grandma to use the infrastructure. She doesn't have to know a lot about private keys and things like that. That could all be managed on her behalf on chain by the system itself. So that would I think increase the utility. So I would encourage people to look at this new algorithm for identity obfuscation. There's a sort of popular write-up in Quanta magazine if people are interested, but it is a game changer for a lot of encryption algorithms, and in particular, it has a significant impact on RChain going forward from a cryptographic and security perspective. Any questions about that?
I have a link you can post so I can read about it.
Sure. Hang on a second.
Is this the one from November or earlier than that?
It's been in the last year. I don't know. Hang on a second. You know what? I'll put it in Discord. I have to. It's not on the top of my stack. Yeah, I'll put it in Discord.
Okay, thanks.
Okay, sure. Yeah, no worries. All right, so two more things to talk about. So one is, so the co-op has signed an NDA with a company called GSI Technologies. They are producing a new chip. It's an interesting architecture that has low power consumption and high performance. So while you know, I guess what I want to say in the big picture, the industry knew that we were going to come to a point of volatility again in hardware design, and that is because everyone knew that the sort of big fat instruction set architecture of the Intel chips was going to be replaced by a new wave of reduced instruction set designs. I was not expecting to see a big market volatility for another 5 years, but it looks like the time horizon has been shortened. So more recently, we've seen Apple's M1. We also see that AMD is really kicking Intel's butt. And GSI is also in the forefront of the wave of what is essentially going to be a period of expansion. So we went through a period of tremendous consolidation with respect to hardware design, and that is coming to an end. We're now going to see a big expansion of new hardware architectures to go and investigate that will largely be about the reduction of power consumption while increasing performance. So that means that we are well positioned because we sort of staked out building a world computer, and we are well positioned to offer the programming language that is the interface to the new hardware, right? If we play our cards right and we really sort of tout the programming model in the right way, Rholang is well positioned to capture the market, assuming that we can sort of plaster Rholang in front of enough of the winner new hardware architectures. So building a compiler from Rholang to the GSI chip, building a compiler from Rholang to the M1 and others are all things that we need to investigate and really starting to get enough experience that we can place some winning bets in this space. So that's kind of how the sort of market analysis and rationale for this kind of work. Any questions about this? And people understand, what I'm talking about in terms of the market dynamics?
What was the name of the company again?
GSI.
Okay, thanks.
Any other questions? This is kind of a big deal. It's really important to internalize what is about to happen with respect to the market.
I'm just kind of wondering what the like what's the ultimate use case? Like, do you envision these chips being put in actual PCs or in phones, or how
Well,
are they going to be utilized?
Yeah, so Apple is already putting the M1 in Mac Minis. It's quite likely that they end up in phones and laptops and a wide range of things.
So this would literally be the beginning of
It's a new wave of compute infrastructure, right? And there will be, because it's low power consumption, you can imagine that it goes into more. You start to see these chips in more things, right? So you'll see these chips in wearables, and you'll see these chips in smart espresso machines and a wide range of devices. And we want to make sure that Rholang runs there. So you can imagine, a shard of toasters.
I don't know if you guys remember, there was a famous speech by Barack Obama talking about his energy policy. And I think the Republicans had made fun of him because he told everyone to pump their tires up. But then what he did in this speech was he said, if everyone pumped their tires up to the right pressure, this is how much we would save in energy. And it was huge number, right? That is nothing compared to the energy savings of the M1 chip compared to the Intel version of the same thing. You're talking about a 90% reduction in power consumption.
Wow, I didn't quite kind of fully grasp that aspect.
Yeah, I mean, with an M1 Airbook, right, MacBook Air, sorry, with an M1 MacBook Air, there is no fan.
Yeah.
It doesn't need a fan. Now, imagine all the times your MacBook Air turns its fan on, right? Well, with an M1, that won't happen. From an audio perspective, it's as big a shift as it is when you see an electric car because you didn't hear it and you jump and think, I didn't hear that.
Yeah, that's actually why I'm in the market for an M1 Air, is because I mix at very, very low volumes.
I have just bought my daughter one.
Really?
And yeah, and it is stunning, the lack of heat. I mean, this thing runs cool. So when you think about RChain and the vision, and you think about Rholang running on these reduced instruction set chips with much lower power consumption, it means that there's the potential to get even more energy savings by using RChain as your blockchain.
Absolutely. And now think about, us packaging up a bunch of M1s or a bunch of GSIs or even a heterogeneous mix into a device that is essentially a shard in a box. So it's not it's not just one node, but it's literally 1,000 nodes in a single box.
So I guess we're talking about like IoT kind of like applications, like my mind is going to drones or to other devices that can all be connected to RChain. Is that kind of the idea?
I mean, IoT is one application, but there's lots and lots. What I was talking about was literally, so you wanna make a passel of money on staking, or you buy this box, you put it under your desk, and you're running 1,000 RChain nodes.
Oh, okay, I see. Right. Yeah, and it would be that much more efficient on this chip as opposed to using some other Apple product, some other server.
Oh yes, right. Because I mean, the main thing that we want to do is we want to get the JVM out of the way, right? The JVM is a big giant hog, right? We implemented it via the JVM to do integration with the wide swath of enterprise code that is all written in Java. But if we're just talking about straight up blockchain, where we don't have to do integration with a lot of other enterprise code, going straight to the metal is fantastic, right? That is, and that's the kind of world that we can contemplate, right? Because we know that blockchain is going to change all of development, right? So the more tools we have in Rholang, the more of a development environment and a lot of things like that, then we can just kind of say goodbye to integration, right? We start with okay, we're playing nice and we can integrate nicely within the enterprise, but over time, the speed benefits and power consumption benefits far outweigh. Like people will suffer a lot in order to get like 3 orders of magnitude speed up. So that they're happy to kind of build their own tooling. And in fact, you know, a lot of programmers, that's what they live for, is to be able to build their own tooling, right? So that's the kind of world that we're about to enter, because there's going to be so much hardware volatility.
So I just wonder, from the action standpoint, what's the path for the members to do so? So should we like reach manufacturers that are building new chips, like you said, toasters and all this stuff, and ideally that they're running their toasters on their Rholang, and all these chips are running on Rholang? So what's the...
Oh, you're asking what actions can members take?
Yeah, so you were saying that this is the the revolution that we're entering into, and that toasters can run a shard over RChain. So what should enable this? Should these chips are programmed in Rholang, or
yeah? So what we're proposing is that for the M1, for the GSI chips, for the AMD chips, we start building compilers directly to the metal. And now is not the time to make too many bets, right? Because there's still too much flux. But now is the time to gain enough experience, right? So that's what it's really all about, is to gain some experience building a direct to metal compiler from Rholang to the GSI chip, Rholang to M1, Rholang to AMD. And once we've done this a few times, then, you know, we have enough experience that we can say, all right, so these are the characteristics that we know really make us tick. These are the characteristics that are coming down the pipe in terms of, you know, the hardware revolution. And so this is where we need to put most of our energy. That's, at least that's my approach. I mean, other people may have, you know, your mileage may vary, but that's what I'm doing, because, you know, we need to be able to speak to the market from a place of experience.
I see.
That's, yeah.
So is this an alternative to, or in addition to, the use of FPGA?
It's in addition to. FPGA is basically us designing our own chip.
Right.
So it's even more fundamental, right?
But
That's
right, it's field programmable, so we can.
Yeah. So what we would do is we would create our own chip that we can plaster onto the surface of an FPGA. So that is definitely a way forward. However, we don't want to be in this little niche where the only place you can use Rholang is, you know, either with the big honking enterprise stuff or with these field programmable gate arrays. We also want to be able to engage the market, and as the market begins to go through a lot of volatility. Now, the FPGA, in a certain sense, is a hedge against that volatility, right? So you can get, you know, a simulated M1 onto an FPGA. It won't run as fast as an M1, but it'll you know, you can, you know, so the point is, you can target a bunch of these architectures in a soft way, or with the ones that are further in development, you know, you can go directly to the source, like with GSI or M1. You see what I'm saying?
Yes, thank you.
Sure. Anyway, so this is why it's kind of important to stay engaged with these technologies, and to, you know, because in a very short period of time, like you know, in technology terms, this is going to be a blink of an eye, and we're going to see a big sea change from consolidation to expansion. And so the co-op needs to be on the you know, on the leading edge of that wave.
That's such a fascinating thought. It's like Intel has been kind of like holding back the gate for this long, and finally, you know, they failed, and the gate has burst open.
Yeah,
It's almost like that. It's wild to think about.
Oh yeah, I knew it was happening. I knew it was coming, right? And at the end of the day, it's you know, we can't stop with just reduced instruction. We have to move to instructions that are explicitly concurrency driven. But that's another discussion.
And I have a question. Is there a possibility that in the future RChain RVote software is linked to a specific processor constructor like AMD or GSI?
I wouldn't recommend that, right? We want to be, we want to have a layer of indirection so that we can run on lots of hardware. Taking too heavy a bet is a bad business decision, in my opinion.
Okay.
Yeah, I mean, like something maybe at the level of RISC-V or some commitment like that may be okay, in that there'll be some people making improvements on that. But even that may be too tight, I don't know.
Yeah, it's kind of interesting, like the whole Java raison d'etre was basically like their idea was write once, run anywhere, but that was happening at a time when the market was undergoing massive consolidation, right? You know, it's like write once, run on Intel. Like even Apple, you know, capitulated and made their servers and laptops in terms of the Intel devices, while running this dark horse in terms of the RISC instruction set on their phones, you know, the iPods and the phones. So there's lots of irony in the way the market unfolded. Okay, so we talked about that, and then there was one other thing. I'm trying to think what it was. Yes. Okay. The board ratified a couple of things. For those who want to know about the recent board ratifications related to Daasl, I strongly urge you to be at the Friday closed door session, because this will, it has an impact for everyone who's interested in Rev. So please come to the closed door session, and we'll talk through the two things that the board ratified yesterday. So yesterday was the first board meeting, and there were 3 votes, and two of which were related to Daasl. So we want to make sure that everyone is aware of that. Ian, what was the third vote? I can't remember.
Prior minutes. It was approval of prior minutes. Yeah.
Prior minutes. Thank you. Okay. Yeah, that was the third one. Yeah, cool. All right. So I think that's it, and we're right near the top of the hour. Any questions or comments before we close it out?
And while we got you here, I was just reviewing Raphael's documentation that he's developing here, and he's talking a lot about namespaces. And the way he talks about them here is they're working almost like shards. Is this part of the roadmap, is to have namespaces and shards, or just that a shard would have a namespace? Go ahead.
Namespaces are orthogonal to shards, except that, you know, each shard has its own namespace, right? But it's not just its own namespace; it's its own family of namespaces, space of spaces, right? So you can always, because the namespaces are infinite in size, you can always bifurcate them, right? You can always take a namespace that's infinite and divide it into 2 pieces, both of which are the same size as the original namespace, right? Just like with the natural. So if you think of the natural numbers, you know, 0, 1, 2, 3, 4, as a namespace, right? So we could use the numbers as a way of addressing things.
So
then you could take the odd numbers as one sub namespace of that one, and the evens as another sub namespace, right?
And these namespaces will serve to help decentralize consensus, or?
The namespaces reduce contention.
Right.
So if you know that one transaction is happening in one namespace and another transaction is happening in another namespace, then you know that those two transactions can't step on each other's toes. So that's what it's all about. And in fact, in general, you can use this same principle to understand that what we're doing inside a shard in terms of block merge and building a DAG as opposed to a chain and sharding, they're all a part of the same idea, right? So within the Rholang family and the pi calculus family, there's only one form of conflict, right? It's either two outputs to one input or two inputs to one output. That's it. That's the only kind of conflict you get. And so with respect to sharding versus the DAG, what's really happening is for a given shard, you've got a paywall, right? When you hit the shard, you've got to pony up something in order to do a deployment. Right. And the reason you need to pony up something is because you have to you have to do that to prevent denial of service. So shards prevent conflict at the paywall, right? So if I have two paywalls, i.e. two shards, then a transaction that hits shard A does not have to deal with any conflict associated with transactions that are hitting the paywall at shard B, right? They're two separate accounting systems, and because they're separate, there's no potential conflict, so they can run in parallel. They can happen at the same time to get through the paywall because they're different paywalls. So it's like if you want to do an analogy to what's going on with the internet today, there's some new GOP story, some news story that you really want to learn about, right? And so you could go to the Wall Street Journal to learn about it, and they have their paywall, and you can go to the New York Times or the WAPO, and they have their paywall, and the two different transactions, right, can run in parallel because they're hitting different paywalls.
Right. So both mechanisms also decentralize consensus because they're independent.
Correct. Yeah.
But you wouldn't have a namespace served by more than one shard, probably, right?
No, that's not true. When you have transactions that are involving resources in two shards, then you're going to have the composite namespace of the two shards.
Okay. Now, as things are right now, we don't really define our namespaces. Where is that in the roadmap?
I mean, we have a very clear definition of what a namespace is. So the namespace is built out of quoted Rholang programs, and then there's a mapping from that onto existing namespace technologies. So there's a mapping from URIs to that, right? There's mapping from addresses to that, right? So, but again, we know that in all of these cases, we're only talking about countably infinite. And so we know we can construct these maps.
So is URI a namespace? I mean, it's flat, right?
No, URI is not flat.
No?
URI is no, right? You have slashes in it.
Yeah.
So URI is not flat, but addresses in like Ethereum or Bitcoin, those are flat. There's no internal structure.
When we get a URI from the registry, it's flat.
Yeah, sort of. It only appears to be flat. Internally, it's not flat.
All right.
Yeah.
Interesting.
All right. But on the other side of the paywall, so you've already done some deployments to a particular shard. So those deployments can have conflicts as well, right? They can both touch the same resource, which is log, hanging off of a given name. And that's where the DAG comes in. So we can detect when you have that situation and essentially boot out conflicting deploys. say resubmit this, and we can package up other deploys that are non-conflicting. We can package them up into a DAG, right? And so being wide, in other words, branching, corresponds to the non-conflicting deploys, and then going deep, in other words, a chaining, that corresponds to when they must be sequentialized, right? So that's the what's going on the other side of the paywall. So you've gotten through the paywall, and you're now handling deploys within a given shard. And once you see that, then it's like you realize they are only dealing with one phenomena. DAG and shard are the same thing, and they're just happening at different points with respect to the transaction apparatus, right? So the sharding is happening pre-paywall, and DAG is happening post-paywall, and that's all there is to it. And Rholang makes this very, very clear. It says these are the these are the kinds of conflicts you can have, and so you can have conflicts at the paywall, or you can have conflicts on the other side of the paywall. So Rholang makes that analysis just dirt simple, like a kindergartner can do this. So and this is all related to your namespace technology, because namespaces are effectively the mechanism by which you're detecting conflict, right? So if you can enforce namespacing up front, in other words, you get a commitment, these contracts are only going to run in these namespaces, which you could get by, for example, a type declaration. Then you can know up front, like before you ever run the contract, that certain kinds of conflicts will be avoided, and other kinds of conflicts are entailed. Does that make sense?
Yep, I still have some questions, but I'll save those for a Monday.
Okay, sounds good. Sounds good. Any other questions or comments? Okay, well, thanks to all. Really appreciate your engagement, and please stay safe, and we'll see you on the other side.